This video is meant to help supplement what was discussed on day 40 in our Prob and Stats class. If you missed the class, you can watch this and get caught up, or even if you were in class and maybe missed something from the notes, this should help you out with that as well. We're going to start the day, or we did start the day, by looking at a review of a card deck, a deck of cards. There are 52 cards in each deck in total. And each of these rows represent what's called a suit. Within each suit, there are 13 different cards, from 1 up through 10 numeric values, and then these royal cards, if you will, Jack, Queen, and King. So that makes a total of 13 cards per suit. 4 suits makes 52 cards total. When I display all of these cards like this, this represents a sample space. A sample space of all the individual cards. Of all the individual cards that I can pick, this is a list of all of them. Now, with this sample space in mind, we can actually answer a few different events or probabilities associated with a deck of cards. So let's consider 4 events. Find the probability that the card selected is the King of Hearts. So find the probability that we pick the King of Hearts. It's a bad looking heart, but hopefully you get the idea. Probability of the King of Hearts. Well, if I go to my sample space, since I have this nicely organized here, I'll just go out looking for the King of Hearts, and there it is. If there are any other King of Hearts in our sample space, then we'd want to count it as well. But knowing that we're talking about individual cards here, this is the only one. So the probability of picking the King of Hearts is simply 1 out of 52. Or in other words, 1 divided by 52 is a 0.19 probability. So that takes care of the probability that the event that the card is selected to be the King of Hearts. Let's look at our next one. What's the probability that the event that the card is selected is a king, just a king period? Well, this one's going to be a little bit more common, a little bit more likely to occur, because all I have to do is find every king that shows up in this deck, and there are 4 of them. So the probability of picking just a king in general is 4 out of 52, or 4 divided by 52. This is a likelihood of 0.77. 0.077 due to rounding. Well, what's the likelihood that the card selected is a heart? Well, again, I can go back up into my sample space and look for all of the hearts. And again, since I've taken the time to generate a very nice, neat, organized sample space here, it's very easy for me to find all of those hearts. And here they are. We have a total of 13 hearts in the deck. So the probability, starting to run out of room here, but we'll try to squeeze this in. The probability that we pick a heart is simply 13 out of 52, or 0.25 probability. I know that's the answer because 13 is a fourth of 52. Watch this. 13 divided by 52 is 0.25. Now, for our last example, we would like to know the probability that the card selected is a face card. A face card are all of these, the ones with the royals on them. So how many do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 chances that you get a face card. So probability of a face card is 12 out of 52. Now this should be just slightly less than 0.25. 12 out of 52 chance is 0.231. You'll need to pay close attention to Math Excel. I'm not exactly certain which method they would like for you to record your answers in, whether they prefer reduced fractions or if decimals are okay. In either event, just make sure that you're reading the instructions at the bottom underneath each question. And so at this point, I'd like to ask the question, how would our sample space change if the likelihood of a pair of cards being drawn? In this case back here, we looked at our sample space, and all that we were interested in were all of the individual cards. So every card individually was laid out. Now I'm considering the idea of a pair of cards. So what if we had an ace, maybe the ace of spades with the ace of diamonds, or maybe we had the ace of spades with the ace of clubs, or the ace of spades with the ace of hearts, for example. Those would be 3 entries in our new sample space. Then I might start looking at other pairs. Let's say we had the ace of diamonds with a 2, oops, 2 of clubs, or the ace of diamonds with a 2 of hearts, the ace of diamonds with a 2 of, I think it was spades that I hadn't used yet. But you get the idea. What's going to happen to the sample space if I start considering all of the pairs of cards that I can put together? Well, I think you would recognize that the sample space gets much, much larger in that event. And the reason for that is because we're not looking at the likelihood of picking a card individually, but a pair. And when we start looking at the pairs, we have to consider what each card, what's the chance that each individual card can be paired with another card. And all of those relationships that compare 2 cards to one another really add up. It makes a much larger group. In fact, the sample space goes from 52 individual cards, and it jumps up to a total of 2,652 pairs. There are 2,652 different pairs that you can create just from these 2 cards. So it gets much, much larger. And so for the second part of our discussion, we want to talk a little bit about probability notation. And we used this as an example yesterday already. If A represents the event that a card is a king, then we can use this notation as a shorthand way of asking us to find the probability that we pick a card to be a king. So P of A is simply this question here, part B, probability that the event that the card selected is a king. Well, we already found that above. That's 4 out of 52. But this notation is going to be an important one for us to use. Similarly, the probability, or I'm sorry, if we identify B is the event that the card is a heart, then P of B would represent this question back here, option C, the event that the card selected is a heart. And we found that that probability was 13 out of 52. Now, where this sample space, or I'm sorry, this probability notation gets to be particularly useful is when we start combining these phrases in their own probability. So this notation here says what's the probability of both A and B occurring. So what's the probability that a card is a king and a heart. So basically we're looking for the king of hearts here. We said that that was choice A, 1 out of 52. Now what I want to show you about these last 2 bullet points is that we can display these using a visual method called a Venn diagram. And I'm sure you've seen Venn diagrams before in perhaps an English class. You might have seen them in your math class as well. But they look something like this. We can use them to help describe probabilities as well. So let's let A represent this left-hand circle and B represent the probability of being in this right-hand circle. What we're looking for are the events that are represented by this statement here. the events that are shared by both A and B. So A and B would occur right here where the two parts of the diagram are shared. Now, I don't have enough room to really show what this might look like, but it would be helpful to recognize that A, the sample space A, we would list all of our kings. So anything in this circle would be a king. So I might have king of diamonds, the king of spades, the king of clubs, and then the king of hearts. And I'm going to list the king of hearts here in the center because not only is it a king that falls into this group, but it's also a heart. And so I'd want to list all of my hearts over here, the ace, the 2, the 3, 4, 5, 6, and so on. And I'd list all of my hearts in group B. And the only part that should be covered by both is the king of hearts. That's the only one that's both a king and a suit of hearts. Now, when we get into probability, we like showing a box around that Venn diagram because these examples here aren't the only cards that might show up in our example or in our sample space. We have all of the other types of cards that might occur as well. So we're talking about the diamonds and the spades and other values or other cards that are not a king or a heart. Those would all be listed on the outside here if we were being very thorough and showing all of our opportunities or events. Now in this last example in this group, we're looking for the probability that A or B occurs. So the probability that we select a king or a heart. Now the chances of doing that are going to be much greater. Let's come back up here and look at our sample space. The likelihood of picking a king, well, we have 4 different ways to pick a king, and we have 13 ways of picking a heart. Now one of those is already included, so if I take the 4 plus the 13, that makes 17 different ways that I can pick that card, but I'm going to subtract 1 off of that because I already counted this king of heart 1 time. So there are 16 ways out of 52, 16 out of 52 that I might select either a king or a heart. So 16 out of 52 is a 0.308 likelihood. Now to finish out this video and our discussion for day 40, I'd like to take a look at the Oreo problem that was introduced on Friday of last week. I still want you to write up your results, so after we're done with this discussion today, I want you to come up with your own solution, but I'll at least give you a head start here thinking about how we can find a solution to this problem. Remember, our job was to determine how many different cookies can we create for the new Oreo company if we use different cookie parts, filling flavors, and then filling amounts. Now, one method that I find that's really successful in determining a sample space is to take one of these parameters and kind of isolate it from the others. And what I shared with some people already is doing that with our filling amounts. What I mean by that is that if I can determine all the different ways that I can put together an Oreo with the 4 different cookies and the 4 different filling styles, if I do that once for a traditional single Oreo, then come back and do it again for the double stuffs, and then lastly figure out a solution for the triple doubles, I could take those 3 sample spaces and combine them together to make our sample space for all of the cookies together. And that technique would work too if I wanted to do that with the cookies. Let's say that I just do one example with just the chocolate flavored cookie and then see all the different ways that I can combine vanilla, chocolate, peanut butter, and mint with the different filling amounts, standard, or I should say single, double, and the triple double. But again, since I shared this with some people already in class, this is the method that I want to show in this video today. Let's think for a minute of all the single stuff Oreos that I can create. For every cookie, I could have a certain amount of filling flavors allowed for it. And the tricky part that you have to remember is that we are allowed to use different different cookies mix and match. So if I start with a chocolate, vanilla, chocolate chip, and strawberry flavored cookie for one part of the cookie, well, each one of those can actually combine with the same chocolate, vanilla, chocolate chip, or strawberry for the other half of the cookie. And we can actually do that for each of these first 4 cookie flavors. Now, you might recognize this tree diagram. This is a good way for us to recognize how many different samples that we can put together. Now, for each of those pairs, we can then combine them with a different filling flavor. Now, in a single Oreo, there's only one filling flavor. So this is where our tree is going to end. We'll have vanilla, chocolate, peanut butter, and mint, and that'll happen for each of these tails. Now, obviously, it's very hard to draw all of these, and we probably won't sit here and try to count the end of each of these tails. And so you might recognize the pattern that's used to calculate this result. Since we started with 4 different cookie options for the first half of the cookie, we had 4 different options for the second half of the cookie, and then again 4 options for our filling flavors. By multiplying 4 by 4 by 4, this tells us that we have 64 different ways that we can make a single filled Oreo. I would encourage you to use this same technique to identify the number of different Oreos that you can make that are double stuffed. Because again, we're done with this single now. We can just focus on a double stuffed filling amount. I would encourage you to think about what the tree might look like for that one, and you can get a sum total there, number of different cookies that you can create. So what I'll do is start talking about the triple double a little bit and let you think about that one as well. Because I don't want to give away too much of this information. I still want you to think about it on your own and come up with a solution for yourself. Now with a triple double, this is the one that has 3 cookie parts and there were 2 fillings. Now for the first cookie, we could use chocolate, vanilla, chocolate chip, or strawberry. And from each of those each of those cookies, we can have the 4 different fillings. So chocolate, vanilla, peanut butter, and mint as a filling. Following that filling, you can go to a different cookie flavor. So you can have chocolate, vanilla, chocolate chip, or strawberry. And then from there, we have another filling and yet another cookie. And so think about how this tree is going to develop. At each of the branches, how many more branches are created? What would that mathematically look like? I know for that first cookie there were 4 options, and for the first filling we had 4 options as well. How many more times and how many options do we have available as we create these additional cookie types for the Oreo company? So keep thinking about it and come up with a solution. I'll give you a hint. The total that I believe is correct for this problem is somewhere between 1,000 and 2,000 different cookie styles. So your answer when you're done between the single stuff, the double stuff, and our triple doubles should be a total between 1,000 and 2,000. Please make sure that you do write up your results for the Oreo problem. Again, this comes from day number 38, I believe, day 38. In addition to that Oreo write-up, there is a new Math Excel assignment that I want you to work on. That's called homework number 13. So please take a look at that as well.